Good morning everyone. Today we are going to conduct one more experiment, the second experiment in our first cycle of electrical machine 1 lab, that is a parallel operation of two dissimilar single phase transformers and determination of load sharing and analytical verification by short circuit test details. Means we are connecting two dissimilar transformers in parallel. The ratings of the two transformers what we have taken to connect them parallel are 200 VA and 2000 VA and 3000 VA, that is 2 kVA and 3 kVA transformer. So here the equipment required for us are voltmeter with 0 to 600 volt and an ammeter 0 to 10 amperes, wattmeter 75 bar 10 amperes range UPF for short circuit test, and ammeter again 0 to 20 amperes range. This ammeter will be connected through load. Okay, and a switch we required, and an auto transformer with a rating of 15 amperes, single phase auto transformer we required. This is the overall circuit diagram to connect two dissimilar transformers in parallel. Here also we'll be having mains and it will be given to auto transformer, or instead of using auto transformer we can connect the we can give supply to the primary winding of a two transformers directly without using auto transformers. Directly we can apply the rated voltage, okay, by means of a supply. Here as it is a parallel operation of two dissimilar transformers, we have to connect the primary winding of both the transformers in parallel, that is P1 and P1 can be shorted, P2 can be shorted, and the shorted terminals of P1 and P2 can be directly given to mains. Again secondaries are connected in series opposition. Secondary windings are connected in series opposition. Here also first we will do the series connection, then we will go for parallel connection. Series connections in the sense we will start from point S1, then ammeter, and the terminal ammeter should be given to one more ammeter of a second transformer, then other terminal of the ammeter should be given to S1, then S2 to SPST switch. Another end of the SPST switch should be given to ammeter, load ammeter, and then load is connected. The another terminal of a load is brought back to the S2. So this is what the overall series connection, how exactly we are connecting the secondary of two parallelly connected transformers. We will be having this ammeter shows current I1 and this ammeter shows current I2. This ammeter means this ammeter current represents that the current drawn by this particular transformer, T1 transformer. Then this ammeter represents the current drawn by the transformer 2. Then this ammeter which is connected across the load, it gives the overall current, means the I1 and I2 additional current. Addition of that current it will be displayed in this ammeter which is connected through the load. So this is what the overall circuit diagram for connecting two transformers in parallel, and this is the overall setup what we have to connect two single phase transformers in parallel. So as I told you, we required an ammeter, two ammeters to measure current drawn by both the transformers, then one more ammeter which is having a rating of 0 to 20 amperes which is called as a load current. Then we need a voltmeter to check the polarities across the switch. Then we are using a load which we are going to apply on both the transformers. Here also the transformers what we use are having 2 kVA and 3 kVA. So these two are what dissimilar transformers, 2 kVA and 3 kVA dissimilar transformers we are using. Now connections, we'll see how exactly to do the connection. Directly we can give supply to the primary winding of a transformer. Here either you can connect two primaries are in parallel first and then we can connect it to a supply, or we can connect one phase to P1, one phase to P1, another phase to neutral to P2, and then P1 of first transformer and the P1 of second transformers are shorted. Again here also the P2 and P2 of the second transformers are shorted. Then secondary connection start from S1 to ammeter of 0 to 10 amperes range, 0 to 10 amperes range. Then it is given to common, again 10 amperes range to one more ammeter, common terminal. Then another terminal of that second ammeter should goes to S1 of the second transformer again. Then S2 of the second transformer should be given to switch. Next, the S2 of the second transfer should goes to switch. Again, another terminal of the switch should goes to the S2 of the second transformer. Then we have to connect the load. Now load is connected from the shorted terminal of the ammeter junction. From there, one line should goes to the load here. So as we are doing a single phase, all the RYB should be shorted. So as of now, let's connect another terminal of the load should come from S2 of the transformer 2, and it should be given to the neutral. Okay, so depend upon the current rating what we required, we can connect the RYB shorted, or we can directly use it as a load. Okay, now here we have a switch, so which is used to check the polarity at the secondaries of a transformer. Then across this switch we have to connect voltmeter. This voltmeter is used to check the secondary winding polarities of a transformers which are connected in parallel. If this voltmeter shows 0 when the transformers are excited, then polarities are correct, means the secondaries of the transformers are connected in series opposition. If this voltmeter shows double the reading than its rated value, then any one of the secondaries, that is S1 S2 of either one of the transformer, should be reversed. This is what the overall connection what we require to do the parallel operation of two dissimilar transformer. Now let's see how exactly the conduction of this experiment goes. Circuit diagram for doing the parallel operation on two single phase transformers is as shown in the circuit. As per this circuit diagram, the overall circuit is connected. The transformers which we use for parallel operation are having a rating of 2 kVA, one, and the second transformer is having a rating of 3 kVA. Both will be operating at an equal voltage of 230 volt. So before starting the experiment, a SPST switch which is connected at the secondary of the transformer should be open position, and there should not be any loads applied. And we will be connecting a voltmeter to check the polarities across the secondaries of the transformer by making use of SPST switch. Now close the supply switch, apply the rated voltage across the transformers. At this instant, we should check the voltmeter to confirm that it is showing 0. That is, the voltage across the switch is 0. This confirms that both the secondaries of the transformers are connected correctly and parallelly. If in case the voltmeter connected across the switch shows double the rated voltage, then we should interchange secondary of any one of the transformer. Once we confirm that the voltmeter shows 0, then we should close the SPST switch. Now we have not applied any load, the ammeter 1 and 2, which shows I1 and I2 readings are 0. Once we start applying the load, both the transformers T1 and T2 starts drawing the corresponding currents as per their rating. I1 is showing around 2 amperes as it is connected to 5 amperes, around 1 ampere it is showing. Next, the I2 will be around 3 amperes. IL will be addition of I1 plus I2. 4 to 6 readings are taken by applying loads in step. As we applied the load, the I1 and I2 values start increasing. It means the two transformers which we have connected parallelly started drawing the current as per their rating. Apply the load, two more steps, then note down all the readings, that is I1, I2 and IN. All the readings are entered in the tabular column provided in the manual. Once all the readings are noted down, we should reduce all the loads. Then by opening the SPST switch, finally we can switch off the main supply. This completes the parallel operation on two dissimilar single phase transformers. But to calculate the impedances of transformer 1 and transformer 2, that is Z1 and Z2, we need to conduct short circuit test on both the transformers, that is T1 and T2 under test. By conducting the short circuit test, we will be obtaining the values of Z1 and Z2 by doing the calculations with the formulas provided in the manual. The short circuit tests are conducted similar to the short circuit test which we have done while conducting OCIC test on a single phase transformer. By doing all the calculations, the practical and theoretical values are verified by entering in the tabular column. So this is all about parallel operation on two dissimilar transformers.